Now what I'm going to show you here is a couple more variations on this more complex integration by substitution techniques. Now unlike the previous video, this isn't going to cover if I've got 1 over square root of a squared minus x squared or 1 over a squared plus x squared. It's not going to cover things relating to inverse trig functions and their integrals. But it is going to be a couple of other areas that we still need to know and that are still useful for us to have the technique to solve. Now the first one is if I have an integral of the form integral of kx times the square root of a squared plus x squared. So I've got kx, a constant, times x outside the square roots, and within the square root I've got a squared plus x squared. Now, quite simply, if I have an integral of this format, what I want to do is use u squared equals a squared plus x squared. So let's look at this here. Let's imagine I've got the integral of 2x times the square root of 3 plus x squared dx. Now you might be looking at that thinking, well, that's not a squared plus x squared. But actually, technically it is if I have root 3 squared plus x squared. So if I do that, what I can then do is let u squared equal the square root of 3 squared plus x squared. Then I can take this, take the derivative of it to get rid of the dx, and then work it through. So if I do that, take derivative with respect to x on both sides, what I get here is I get 2u du equals square root of 3 squared, derivative of that with respect to x, well no, I then get 2x dx there. Now what you'll notice is that this u squared, being this part here, is the equivalent of in the square roots, and this 2u du can now be used to get rid of the 2x dx. So I can write the entire integral in a slightly simpler format in terms of u, and then use that to integrate it. So I can then say it's fine, so my integral I becomes the integral of the square root of u squared times 2u du. Now, from this, what that means is the square root of u squared is just simply u, and I can then combine it all together and make that much simpler in the format of 2u squared du. Now that's a heck of a lot nicer looking to integrate than this up here. So integrate this as a standard would. So I've got 2 times u cubed divided by the 3, then plus my c, my constant of integration, and I then substitute back in for u. Well, I know that u squared is equal to that. So I can then say is that I know that u is equal to the square root of 3 plus x squared. So what I can then do is put that back into here, and I get 2/3 times the square root of 3 plus x squared to the power of 3 plus c. I can write that as a singular power here, and I'd get 2/3 bracket 3 plus x squared to the power of 3 over 2 plus c. So I could write it in that format or that one there. Just be careful, it might ask you for a set format, it might not. Both are acceptable answers either way. The second one I'm going to talk to you about is if you've got an integral of the format sine to the power of n of x times cos to the power of m of x dx. Now, I want you to think about this, and I want a key thing that you think about being if one of n or m is odd. So one of the two of them is odd. If that's the case, what you do is you associate one of the factors of that odd power with the dx, and then use the correct substitution from sine squared x plus cos squared x equals 1 to transform the rest into the same trig function as the other part. Once we've done that, we can integrate it using the standard technique that we know. Now let's imagine I'm going to take this one here. So I've got integral of sine cubed x cos squared x dx. Now one of them is odd. The odd one here is this one here, sine cubed x. Now we know that we can write sine cubed x as being sine squared x times sine x. And that's how we have to think about it. Because what I have to do is associate that sine x with the dx. So I would take my integral and I'd make it become sine squared x, cos squared x, then sine x dx. Now, this bit here is important because what's going to happen is this is going to come into play later on for us to be able to use. Now at this point, what I'm going to do is I'm going to choose u equal to cos x. What that means is if I then take this and calculate the derivative, du, what I end up getting is negative sine x dx. So actually you can see already that I'm going to get rid of the sine x dx and substitute it for negative du. So what I've already done is I've already gotten rid of that there. What I can also do is take sine x squared and rewrite it using the sine squared plus cos squared equals 1 as 1 minus cos squared x. So what that then allows me to do is write my sine squared x as 1 minus u squared. So what I can then do is take this and substitute the whole lot into here, and I get that my integral I becomes the integral of 1 minus u squared times the cos squared, so times u squared there, then times the substitution for the sine x dx times the negative du. What I'm going to do is multiply out the bracket here. These are both the same highest power, so multiply it out, and I'll then get the negative integral of u squared minus u to the power 4 du. Now that there is much simpler and straightforward to integrate. What it gives me is negative bracket u cubed over 3 take away u to the power 5 over 5 plus my constant of integration. What I can now do is substitute back in for u and then rewrite my equation out. What I'm going to do as well is get rid of the negative by multiplying out the bracket, and what that then gives me is cos x to the power of 5, 1/5 of that, or over 5, minus 1/3 cos cubed x, sorry, plus c. So there you go, I've written it in that format there. Now, one thing you're maybe going to ask yourself is why did I choose u equal cos x and not u equal sine x? What to do is when you've done this section here, associated one part of your trig function with the dx, pick the other trig function as your substitution. Because what that'll then do is allow you to rewrite the du in terms of the function you've associated with it. And if you can do that, you're laughing, you'll manage it, no problem. Just bear those steps in mind for those two types of functions as well, for when we're doing our substitution and picking the format we want to put in.